Hello everyone and welcome to Part 7 Control Flow. In this lecture we're going to be discussing the Python syntax for control flow, and this will include operators, if, else if, and else statements, and loops, like for loops and while loops. We won't cover the main principles behind these topics, hopefully you already remember them from the JavaScript lectures. We'll just cover the general syntax and what makes Python a little bit different than other programming languages for some of these control flow operators. Okay, let's get started. Alright, so let's begin our discussion with comparison operators and logical operators, and I've copied and pasted here from the notes because we won't need to code that much. A lot of it's pretty straightforward. So for greater than, you just use the greater sign or greater than sign. Less than is the less than sign. You have greater than or equal to, less than or equal to, and then for equality, it's a little different than it was for JavaScript. So there is no triple equal sign in Python because Python will automatically check for types to be different or the same. So let me show you an example of what I mean by that. So here I'm going to say 1 equals 1, and it says true, but if I say 1 equals equals and then I pass in a string 1, I get false. So there is no type coercion in Python like there was in JavaScript. So if I say hi is equal to bye, then this is a really clear case where it should be false. Okay, so again, for Python, it's just going to be two sets of equal sign, and for inequality, it's just an exclamation mark. So we can say 1 not equal to 1, that's false. 1 not equal to the string 1, that is true. Now let's discuss logical operators of Python. I think this is one of the coolest parts about Python. The logical operators are just literally the words and or. So that makes reading logical operators of Python really simple, even if you haven't programmed before. There's no ampersand or pipe operators here. So again, it's just the keyword and then the keyword or. And you can have multiple logical operators like this, or, and or. Now let's move on to discuss if, elif, and else statements, or else if statements. And before we begin to talk about that, something to note with Python that's going to differentiate itself from other languages is that indentation is extremely important in Python. And it's basically Python's way of getting rid of enclosing brackets. So in a lot of other languages, you're going to be using enclosing brackets a lot, as we saw with JavaScript. These don't really occur in Python. The reason for that is because Python really stresses readability due to whitespace, and that whitespace comes from indentation. So let me show you some examples of if, elif, and else statements. If I want to have an if statement, and let's actually quit Python here so then I can run this code. I will clear my screen, and then what I'm going to do is say if 1 is less than 2, and then a colon indicates the code block. And I hit enter here, note that it automatically indents for me. And if you're working with any IDE that recognizes Python files, it should automatically indent for you. And then I'm going to say print yes. So now if I run this, I will say python notes.py, hit enter, and I get a yes output. So the main features here, we can zoom in a little more just to make this really clear, is for any control flow statement with Python, you have the keyword operator. Here it's if, we'll see else and for loops, etc. You don't need to worry about parentheses here. You just type in whatever you want to actually compare or whatever the Boolean operator is. Then a colon here indicates that you're going to start a new code block. And then the code block itself is indented, and everything that's indented at the same level belongs to the same code block. So if I want to have a nested if statement, so for instance, if 2 is less than 3, print true. So let's save this and let's zoom back out a little bit so this isn't so massively zoomed in. And then let's actually run this and we get true. So now let's make one of these false. So I'm going to say if 20 is less than 3, and then I'm going to print first block here, and let's change this to say second block. So note what's going to happen here. First off, in order to run anything that's indented past line 1, this has to be true. 1 has to be less than 2. So then we go along and we see print first block, so that is true. Then it goes to line 3, If 20 is less than 3, that's not true, so nothing is going to occur, and line 4 won't execute. So now if I run this, I get first block only. So again, hopefully you can begin to see how the indentation works here. And this block of code is all indented at the same level, so it runs together. And then this block of code is indented in, so this is the top level for this block of code. So again, it's just a colon and indentation. Okay, so that's the basics of an if statement. Let's see an if-else statement. I can say something like if 1 is less than 2, print hello. And then if I want an else to be attached to this if statement, all I have to do is line it up. So then I will say else, colon, print last, let's just say last, save. So then run the notes here, and I get hello to print. Now let's change this so that is 1 greater than 2, which is not true. So if I run this, then I get last. Again, main idea here is you have a colon instead of the curly brackets and the parentheses from other programming languages. And then finally, if you want to add more conditional checks, like an else if in JavaScript, you just use the single phrase elif, which is short for else if. So I can do something like this, elif, and then some condition here, so elif 3 equals 3, print elif ran. We save this, and now when I run Python notes, it says elif ran. And that's because this first condition wasn't true, and this elif condition was true. So note what's happening here. These are all lined up together on their indentation. So if I have something, let's say, if 1 is equal to 1, colon, I could grab all of this and then hit tab, and now these are all lined up with each other. So note here how indentation is really making it clear which code blocks belong to which conditional checks. All right, so that's the very basics of if, elif, and else statements with Python. Again, really want to point out here the white space and the colon is what's defining code blocks, instead of like normal programming languages where you have parentheses and brackets. And this really emphasizes how fast you can code with Python, how readable Python is, and how much time you're going to save working with Python versus other languages. Okay, so now let's go ahead and move on to a big topic, which is loops. We've already covered loops in JavaScript, so we won't define here the general principles behind loops. We'll just show you the syntax for working with them with Python. So first off are for loops. And for loops are going to behave a little differently depending on what you're working with in Python. So usually you're going to be using a for loop with a sequence, and a sequence can be something like a list. So let's create a sequence, 1, 2, 3, 4, 5, 6. And the for loop syntax for Python looks like this. You say for some item in the sequence, colon, and then whatever you do is code here. So then let's just say print that item. So hopefully this looks a little familiar from the for of or for in loops in JavaScript. And then if I run this here, I get 1, 2, 3, 4, 5, 6. So you can see I kept printing it every line. Or what I could also do is say print hello. So if I save that and run this, I get hello, hello, hello for each item in the sequence. And I can call this whatever I want. It doesn't have to be item. So I always make this really obvious by saying something like jelly, and then I'm going to print jelly every time, save that, run this, and I get back all the numbers in that sequence. Okay, hopefully that's pretty clear. It's just for, and then whatever variable you want in the sequence, and then you do some action for each of those variables. Okay, so that's how you iterate through a list. If you end up calling a for loop on a dictionary, so let's make that. Let's say D is equal to Sam 1, and let's say Frank is 2, and Dan is 3. If I say for item in D and say print item, if I save that and then see what this looks like, it ends up printing out the keys, Sam, Dan, and Frank. But notice it's not printing them out in order. And remember, that's because dictionaries don't retain any sort of order. So if you're ever going to use a for loop with a dictionary, don't count on it happening in order. If you actually wanted to get the keys out, what you should do is something like this. You can say for k in D, since we are just printing out keys, we can say print the key and then print D of key. And this is how you can print out, if I run this, what Dan is 3, Frank is 2, Sam is 1. Again, order's not ever going to be the same when you're going through a dictionary. There are also methods you can call off a dictionary to get all the items or all the keys. So I could say dot values to get all the values, dot keys to get all the keys, etc. But we won't actually cover those right now. If we ever use them in Django, I'll be sure to clarify what we're doing there. But again, dictionary with for loops, it's automatically going to be the keys. All right, let's delete that. And now let's talk about iterating through a tuple and about tuple unpacking. So a lot of times, built-in functions in Python are going to end up giving you structures that look like this. It'll be a list, and inside of that list, you'll have tuples that look like this. So 1, 2, 5, 6. So what do I have here? I have a list of 3 tuples. So if I say for item in my pairs, print item, I'm going to save this, run it. I get each tuple out, 1, 2, 3, 4, 5, 6. But what I can also do, and this is a special case, is if I have a sequence that consists of tuples, I can do what is known as tuple unpacking of Python. So I can kind of type a tuple here and say something like tup1, tup2. And then I'm going to print tup1, and then I will print tup2. So if I save that, basically what happens here is I'm unpacking that tuple in my for loop. So I run this, and I can get 1, 2, 3, 4, 5, 6. Or if I switch out the order here, I should get 2, 1, 4, 3, 6, 5. So let's do that. Save it, run this, and I get 2, 1, 4, 3, 6, 5. Because note, it's printing out the second item in the tuple and then the first item in the tuple. So that is tuple unpacking, and you usually don't see it with these parentheses. You usually see it just like this. So if you ever see something like this, don't be confused or intimidated. It's just tuple unpacking. And this sort of formatting is really commonly used in Python, so tuple unpacking is definitely something we'll be working with in the future. Okay, so that's really all you need to know about for loops. Let's quickly discuss while loops with Python. So I'm going to delete this. So while loops, again, allow us to continually perform an action until a condition becomes true. And it's really simple. I'll show you a quick example. We'll say I is equal to 1. And then we will say while I is less than 5. Then colon, that indicates the code block. We'll say print I is, and then we'll use print formatting here. Pass an I. And then we will say I is equal to I plus 1. So again, really simple example. Let's clear this. If I run Python notes again, it says I is 1, I is 2, I is 3, I is 4, and then once I is equal to 5, it's no longer less than 5, so the while loop breaks. So it's just a colon and white space indicating the loop. Now let's quickly discuss a few more useful topics to know, since we're talking about control flow. One of them is the range function, and range functions can quickly generate integers for you based on a starting point and an ending point. So if I do something like, well, let's actually show this with Python over here directly in the command prompt. So if I do something like 1, 2, 3, 4, 5, I have a list that goes from 1 all the way to 5. But I can use range to help me out. In Python 3, if I just type range 5, I get back this range 0 to 5 object. What I have to do is say list range 0, 5, and then I actually get back a list 0, 1, 2, 3, 4, where the first parameter in range is the starting index position, and the second one is the end index position. And I can add a third argument indicating a step size. So I can say list range, and let's go from 0, 20, and then I'm going to type in 2. I hit enter, and I get all the even numbers that go up to, but not including, index 20. And try to remember back to slice notation. Sometimes students are confused. They expect a 20 to show up here, but it's not including 20. So if we wanted 20, we would have to say 21. We'd have to say 1 greater there. All right. Now, another question you might be thinking is, well, what is range 0, 5? What is that, and why did it return that? That is a generator, and basically what that means is it's going to generate the items or elements in this list instead of saving it all to a list. And that saves your computer memory. So instead of having to store this entire huge list in memory, because let's say you had range and then some humongous number, you wouldn't want your computer to have to save this entire list if you're just going to iterate through it. What you want is just a generator where it remembers the previous number and then adds 1 and then saves that previous number, adds 1, saves it, and it keeps deleting, so it only has one number in memory at a time. And it knows the formula to get to the next number. So for instance, it would say, I remember 2, I add 2 to it to get 4, get rid of 2, now my current number is 4. Oh, you want the next number, add 2 to it, now I have 6, get rid of 4 for memory. And that way we go along just remembering one number. And that's kind of the idea behind a generator. So you can actually then use something like for item in range, and usually you see something like 10 print item. We'll save that, and then let's quit Python here, call python notes.py, and here I can see I'm getting 0, 1, 2, 3, all the way up to 9. So it doesn't include 10. Remember, it only goes up to 9 here. Okay, now let's quickly recover list comprehension. We mentioned it before, but let's show you a more practical example now. Imagine I have the list x is equal to 1, 2, 3, 4, and I want to create a list of those items squared. I could make an empty output list, just with empty brackets there, and say for num in x, so in my list x, take out, and then append num to the power of 2. And then say print the output. And note that the print out is lined up with 4, meaning it's going to occur after this entire for loop has ran. So I will save this, run python notes.py, and here I can see I get 1, 4, 9, 16. So that's how you would do this with a normal for loop. But if you ever find yourself running a for loop like this and always appending something to a list from another sequence or another list, the way you can do this is write this as a list comprehension. And what you do is you essentially break down this for loop. So we take the original x here, and it says for num in x. We change this out. We get rid of it completely. Change it here. Make this into a bracket, and then make what we have on the append go in front of the for. And that is the basics of a list comprehension. It's just a for loop rewritten in a flattened form. And then we can say, call this whole thing out. Whoops. And then let's print it. We'll say print out, save it, run this, and we get 1, 4, 9, 16. And those are the basics of a list comprehension. Okay, that was control flow of Python. If you have any questions, feel free to post to the Q&A forums. Thanks, and I'll see you at the next lecture.